The problem with RFI is that our amateur radio transceivers, receivers, can receive signals, noise, in the amateur radio bands that we don't want to have. So that's one kind of RFI, is the RFI that actually interferes with our operations, makes our noise floor higher, covers up weak signals. And then the other part of the RFI is RF that we is part of our transmissions, part of SWR on antennas, part of loose connectors, part of misadjusted amplifiers or antenna tuners. In fact, we had a club member here at our local club that was having problems. Every time he would speak on 80 meters, he was trying to use a G5RV. Every time he would speak, the radio would actually fold back, and it sounded like his microphone was breaking up. And so we thought, well, maybe it's his microphone. We replaced the microphone. It wasn't it. Then we thought, well, maybe it's the power supply, and that the power supply could not supply enough current. That wasn't it. It was RF on the shield of the coax. And just by using a line isolator, Bob, this is RG400 coax wound around two number 31 toroids. These are 2.4 inches, and this one has about 11 turns. We put this in between his antenna tuner and his radio, and voila, no more breaking up, because there was RF coming back down the shield every time he talked. And here's one of those number 41 toroids. Notice it's got the blue markings, and we're going to start the slide deck here, and I'm going to show you that at DX Engineering, we mark all the toroids. So even if you put them in the junk box, they're all marked. And here is the selection chart. You can find this on the DX Engineering website, but this shows all the various styles of ferrite toroids. And these ferrites are just, they're magical devices when it comes to radio frequency interference. And they come in lots of styles, and they come in various mixes, and those mixes determine what frequency area they're going to work the best on. And so go to the DX Engineering website and take a look at this, and you see at the bottom of this slide here the various colors. The number 31 is blue, and that is the best for the HF bands. There are toroids that even work better on 160 meters and 80 meters, and those would be the green and the pink. And then there are toroids that are have the better mixes for the VHF and UHF bands. So you want to make sure that you select the right toroids for your application. So let's take a look at a couple of applications here. Here is these beads here. These are number 31 beads that go over the RG213 or DXE 400 Max coax cable. There's 40 of them here, and this is an optimized choke for 160 through 20 meters. It will work on 15 and 17 and 10 meter bands, but what this does is stops all of the RF that can be on the outside shield of the coax cable. We want the RF to be on the inside conductor. We want that outside shield to be cold. We don't want RF coming into it, and we don't want RF coming out of it. And so this can really solve a lot of problems. This is known as a bead choke, and I use these at the feed point of every one of my antenna systems here at K3LR. And also, once the feed line comes into the shack, I use one just before it hooks up to the watt meter. And you can see there's the weatherproofing here. This is shrink tube. Once you put these beads over the coax, you can then put the shrink tube over it, shrink it down, and it's good to go. So the next slide shows one of our, this is a linear amplifier package that has some clamp-on beads. And the clamp-on beads allow you, so you can go around wiring, AC wires, and other control wires without having to take the connectors off. So they actually split apart and then can be reassembled with the plastic carrier. But we have a little sheet, some documentation, and enough of these toroids to calm down any RFI that you might have between your amplifier and your radio. So we've done some research to package this stuff together for your HF amplifiers. And let's go to the next slide, Victor. Here's the number 31 toroid that I talked about. We sell it in a nice 4-pack, all marked so that you never have to worry what is the mix. These are 2.4 inches in diameter on the outside and 1.4 inches on the inside. And I wind DC cables around these. I wind my relay cables. Any cable that goes in and out of the radios here at K3LR has ferrite on them. And why? To make sure that they're RF cold. We don't want to have RF floating around, causing interference, or in the case of RFI, getting into things like power supplies and Ethernet switches. So next slide. And here, this is showing these clamp-ons. These are really great devices because a lot of times you can't take off the connectors that are on the cables that you want to protect. So we sell some combo packs. These, again, are the number 31 mix. That is the best mix for HF, and these do a tremendous job. You need to remember that the power in the choking capability of all of these toroids is as many turns as you can get on them. So you don't want to just have one turn. If you can do 2, 3, 4 turns, it goes up by the square of the turns, the choking efficiency or the common mode rejection. Next slide. And here is another feed line choke. I like to use this sometimes in the shack. This is used on RG400 cable. It's about the size of RG58, but it's a Teflon dielectric, so it can handle the full legal limit power. And then there's some small beads. These are actually number 43 beads. And this works on all bands, very effective from 160 meters through 6 meters. And you just slide the beads over the coax. We supply 2 connectors, and along with the heat shrink tubing. And this is a great choke. It's more flexible than the larger beads. It's a little lighter weight, and it works very, very well. This choke was designed by W0IYH, who unfortunately is now a silent key, but I've been using the IYH CFC 50 chokes for years, and they keep the RF off the outside of the coax cable. Next slide. And here are some other low-power chokes. If it's just for a receive-only system, the Yankee Clipper Contest Club came up with a really nice choke just using 2 ferrite beads. And they've got a little kit here. This has got F connectors on it, so it's intended for a 75-ohm system that you might have with an active receive antenna or maybe even a beverage antenna. Again, you don't want to have noise get in the way of listening for weak signals. And these are very, very effective, providing more than 5,000 ohms of choking impedance. Next slide. So here's that line isolator I talked about. You can have a line isolator that you just wind yourself with the cores, which is what I showed initially, or we have the line isolator in a nice plastic box, so you can use it outside if you like, at the feed point of an antenna, maybe the feed point of a vertical, or even on a Yagi antenna. And also, these I use these all over the shack, and they work very well. Again, it's a very simple concept, just the ferrite core, the number 31, a pair of them, and the RG400, which is double shielded Teflon dielectric with a stranded center conductor and wound around the toroid, very closely wound. You want to make sure that those turns are right up against the toroid for maximum efficiency. And the next slide. And here's another receive choke, very similar to the Yankee Clipper choke, but actually has even more choking power, designed for low noise receive antennas, a 75 ohm system with the F connectors on the chassis. Next slide. And when you're thinking about your station, whether it's a large station or a small station, even small stations, it's really important. This book that has just recently come out in the last year or so, it was written by Ward Silver. It should be on the New York Times bestseller list because it is absolutely a fabulous book. He's got a lot of information about how to use ferrite for chokes and to lower your noise floor and to take the RF out of your station. And he also has a lot of information on best practices for grounding your station. Many of us don't hook up the ground lug on the back of the radio, and we really need to do that, but there's a right way and a wrong way. And it's all explained in this book. It's a very easy read. I keep this book handy all the time, and I go back, and every time I reread a chapter, I learn something new. So I can't emphasize how important it is when you want to get the most. Look, you're spending hundreds and thousands of dollars to put together a station. Why not make it work as good as you can? Next slide. And so you can come back and replay Ham Nation on YouTube, and you can take a look at these links. These are my 4 favorite links for resources on how to build chokes. So you can save a lot of money if you build your own chokes. Get the cores, get the coax, and you could. This K9YC Jim Brown is an excellent engineer. And he has got a choke cookbook. And if you just Google K9YC choke cookbook, it comes right up. The PDF is there. And he has got so much information that is very, very valuable to anybody that is having trouble with RFI. Also, Chuck Councilman, W1HIS, if you Google him, he has a very nice article that he wrote. It's a PDF, and wait till you see how much ferrite he's got. He's got it all over the place, and it lowers his noise floor and lowers the interference. And then N0AX Ward Silver gave a nice YouTube presentation at Contest University, and you can watch that. He actually will teach you how to do grounding and bonding, and also he puts in there some of the chokes and the PowerPoint slide deck that he used at Contest University is available right on the Contest University website under videos and files. There's lots of stuff up there, but these slide decks on grounding and bonding are absolutely phenomenal that Ward did. So make sure you go take a look at these resources. You'll learn a lot. If you have questions, you can always email me or email Gordo or email George. We'd love to help you take care of whatever RFI problem. Maybe we can give you some hints. And if you have the other slide deck available, there we go. So here's another application. I wanted to show you. This is the number 31 mix toroid. This is in a receive application. There are 27 turns here, and I use these on my low noise receiving antennas for 80 and 160 meters. And these chokes have over 10,000 ohms of choking power, and they're very easy to build. Put them in a plastic box, and this is even smaller coax. This is RG179 that is wound around there, but you use the tie wraps to hold them in place, and it just does a phenomenal job. And the next slide. Here we are. These I talked about the NUC computers, NUC from Intel. These are the computers we use here at K3LR. We've got 25 of these things in service right now, and all of the DC lines and the signal lines have ferrite chokes in place. Bob mentioned when he visited here, he was just flabbergasted at all the ferrite that was here, and that is to keep all the interference down. So we don't want to get RF into the computers, and we don't want the computers to generate any noise that we might hear in the receivers. So it works both ways, and this is on the 12-volt DC supply going into the NUC computers. Next slide. And here is the WRTC, the World Radio Team Championship setup that I used in Germany. and this was actually the test setup that I used. And you can see all of the chokes that were installed that I used with the IC7610. You can see these are all number 31s on all the control cables, because every control cable, every speaker cable, every Ethernet cable can be an antenna. So you just can't choke one of them. You got to choke them all, because you don't want them to act as antennas. There were teams at WRTC that did not use ferrite cores that had interstation interference. We had zero. And it was all about grounding and bonding and the correct use and winding of these ferrite cores. It doesn't make, you're not going to win any beauty contests, but it's sure going to make your station work better. You're going to hear better. It's going to take the noise floor down significantly, and your microphone won't be hot anymore. You know, you get your lips close and you get bit. The ferrite is the magic in the magic here at the station at K3LR, and it can be the magic for you too. What do you think, Bob?
Well, I knew going into this that you were going to be the master, because you have such an extensive station there with 11 full power. We're not talking about little 100-watt jobs. We're talking about big stuff. And I appreciate you giving your secret, so to speak. But the thing that I find so often, I'll have guys call me and say, I got RFI, what's wrong with this microphone? This does not generate any kind of signal except audio. It does not generate RF. It's the way your system's hooked up. Well, it don't happen with my hand mic. Well, you have longer cables. You have all different connectors. And the key to this is, and I just really praise you guys on this one, Tim. They'll say, well, I need an RF bead. No, that's like saying I need a tire. Are we talking for your Volkswagen? Or are we talking about for bus? Are we talking about an airplane? Tire. There are all kinds of them. And you have to be very specific. And boy, DX Engineering did it on this one. I love that you've color-coded them and helped the guys to be able to look at that chart. And they can come back and make the favorite this program, because there's a lot of information there. And I really appreciate you doing that. And we'll maybe come back and have a chapter 2. And we got some thoughts that Tim and I are working on to help everybody get rid of that crazy RF, because it's out there and it's roaming around, and you have to be able to stop it. I have one little trick I want to show you. This does not work. Now listen to me. This does not work for everybody, but I've helped a lot of people. It just depends on how their grounding system. You take the connector. That's the connector that goes into your radio. It's on the end of our cables, the end of our adapters. Pull that little shell back. And what you need to do is take a straight piece of wire on the shield. It'll probably be pin 7 on an ICOM. You take that wire, pull it back through, and attach it to the little screw on the cable clamp. And when you put it all back together and tighten the ring, what have you done? You have absolutely assured that the shield is going to be connected to the chassis, because surprisingly enough, not all transmitters have that shield grounded to the chassis. So that's a little trick. But sometimes it doesn't work. Sometimes it creates. But as Tim has been telling you, you have to try different things. And I hope that this has been of help to you. And let us know. Email us. Let us know. And if you don't be afraid, don't be shy. No questions dumb the first time, right, Tim?
Absolutely. Yeah, we want to have guys have fun and not get frustrated with their stations. And so, you know, I had to learn this stuff. You had to learn this stuff, Bob, from others. And so we want to help, you know, the new guys and inexperienced guys experience the magic of ferrite. because it is amazing the results that you can get.
Absolutely. I'm still learning, by the way, because, see, I haven't grown up because I don't know what I want to do when I get big, and I'm learning all this stuff. Thanks very much. I look forward to hearing from all of the guys, and I'm sure you do too. If you guys ever get a chance, you need to go visit K3LR. What a crazy place. Wow. All right. Well, here's a crazy place.